I tested and compared the QIDI X-Max 3 and the Creality K1 Max. Result? I neither like nor recommend them. Stay tuned for more. That was a short one. This video is sponsored by PCBWay. PCBWay offers a wide range of services like 3D printing, CNC machining, sheet metal fabrication, injection molding, and of course PCB production. You work on an electronic or mechanical project you're proud of? Heads up guys, PCBWay hosts another project design contest. Submit your project until January 15th, 2024 and you have the chance to win awesome prizes. Do not miss that! Check out PCBWay.com, link in the video description. I was quite excited and curious when Creality and QIDI announced their new lineups for fast printers. Judging from teasers, trailers, specs and appearance, some models or parts of them might be labeled as greatly inspired by Bambu Lab. Bambu Lab printers might be worth the money, but they aren't cheap. The machines are fast at high quality printing, but they are limited in build space. QIDI's and Creality's counterattack for market shares are aiming at lower price tags and more choice in build volume. I was interested in their larger sized models, Creality K1 Max and QIDI X-Max 3. As big and fast is the pinnacle in my opinion. The focus of the QIDI X-Max 3 firstly lies on the build volume. 325 by 325 by 315 cubic millimeters. Creality's K1 Max is a bit less at 300 by 300 by 300 cubic millimeters. As always, we have statements for speed, acceleration and flow rate. The promise of this video, we will verify those figures. Both machines arrive well packed. Creality even sent the printed cardboard box in a wooden crate, which was packed in cardboard. Safety first. Both come with quite a lot of similar accessories, tools, extra hot ends, high-speed filament and the other quite usual stuff. There are differences though. The X-Max 3 comes with a passive dry box which is meant to be attached to the rear of the printer. Concerning the overall appearance of both printers, please leave a comment if you find the X-Max 3 more appealing than the K1 Max. And please explain why. I personally really like the appearance of the K1 Max. Though it seems that the assembly process and the tolerances of the casted aluminium is not perfectly refined. There are gaps here and there, and the assembled frame does not align properly. Looking at the X-Max 3, all you see and feel is plastic. A whole lot of rather cheap plastic, which talks to you when touching. Plastic bomber. Nevertheless, the supporting frame of the X-Max 3 has a quite similar design like the Bambu Lab X1 and P1 printers. Welded, robust and well designed from a functional point of view. In comparison to this, the K1 Max appears rather flimsy and misses something. There is no connection between motors and front idlers, which is rather essential for the stability on Core XY designs like these. The biggest problem with the design approach of the X-Max 3, it needs space. A lot of space in comparison to the K1 Max. Build space to footprint efficiency is better on the K1 Max. In addition, it comes with a quite nice integrated camera. The X-Max 3 lacks a camera, but it accepts USB cameras which can be positioned inside the chamber. The cable routing can be done quite easily. Both printers feature a chamber fan, and both include activated carbon to help with plastic smells coming from the cavity. Is that effective? At least it's better than without. Printing ABS, there is a bit of smell left, but it's bearable. Both of the printers feature one-sided external part cooling fans, just like Bambu Lab and just like do-it-yourself guys did it years before. The X-Max 3 comes with a rather large resistive display, which works well for me, no complaints from my side. K1 Max comes with a very nice capacitive display, which I like a lot. Super responsive with quickly reacting from software side, vibrant colors and great contrast. Though there is no real disadvantage with the X-Max 3 display. It's big, you can read everything and UI performance is good, except for thumbnails. The setup process for both printers mainly happens over the display. The nicely made manuals are supporting additional information. On both, that installation and calibration process is absolutely well guided and fully automated, including measuring the resonance frequencies for input shaping. There is one exception for automated setup on the X-Max 3. You manually have to set the set offset with the paper method, or plastic card method in this case, as it is probing with an old school BL touch, which feels a bit like 2015, where the pain threshold was higher than today concerning convenience. Anyways, summed up, unpacking and setup is really easy and intuitive, including the print of a fast pre-sliced 3D Benchy, which is fashion now. The electronic department of the K1 Max is located at the bottom of the printer. It uses the same 32-bit mainboard with the TMC2209 motor drivers as the regular K1. In addition, we find an SSR for the AC heater of the print bed, which is shielded with a transparent acrylic. We also locate a rather small 150 watts 24 volt power supply unit for supplying the DC consumers of the system. All in all, everything looks nice and tidy, also concerning the wiring as well as the AC grounding to the frame. The K1 Max features interfaces for power as well as Ethernet at the rear and a USB-A connector at the front. The XMAX 3 splits the electronics to the rear of the printer and to the bottom of the printer. At the rear we find an NKS mainboard, also including TMC2209 motor drivers as well as a 64-bit Cortex CPU. We also find an external MOSFET which powers the print bed. The wiring at the back is performed rather semi-professionally and doesn't reflect QIDI's industrial-grade approach coming from the marketing. The 300 watts chamber heater is directly powered by the mainboard. Unfortunately, it is also directly heating the wiring of the print bed. I am not sure if this can go well for hundreds of hours, as I don't know the used materials of the wiring protection. I'll consult QIDI on this. At the bottom we find two 450 watt Meanwell power supplies, which are also properly grounded to the frame. The XMAX 3 features a power inlet as well as an Ethernet connector at the rear and a USB-A connector at the top. But now it's time to have a look at the print beds and bed meshing, as there are quite interesting differences on both printers. Maximum temperatures for the print beds are 120 degrees Celsius on the XMAX 3 versus 100 degrees Celsius on the K1 Max. Going over 100 degrees Celsius is hardly ever necessary for these printers though, you'll see during the printing tests. Creality got heavily inspired by Bambu Lab's Core XY printers, 3 lead screws and 1 stepper motor to move the bed. The aluminum bed is very thin and it is equipped with a strong magnetic sticker to hold the smooth spring steel print surface. Adhesion is actually crazy high, so Creality recommends using a glue stick for easier release of the parts. The 6mm thick and sturdy aluminum print bed of the XMAX 3 uses embedded magnets in order to hold the included textured PI spring steel print surface. The print bed of the XMAX 3 is moved by 2 lead screws, driven by 1 motor and supported by 4 steel rods. The sturdy and approved old school way. On the K1 Max, at some point I tried Magic Glue adhesives depending on the material, as it has a nicer release and it's not that sticky at the bottom. Big thanks to Thought 3D for providing a set of those. The heat up times for the print bed take way longer on the XMAX 3 in comparison to the quick K1 Max. On the XMAX 3, the surface settles into around 95 degrees Celsius to 98 degrees Celsius after 20 minutes. This might be a bit below set temperature, but wouldn't cause problems in real-world printing. Also because heat is very evenly distributed. Here, the bed of the K1 Max is not good. Even though it's quickly heating and though it actually reaches 100 degrees Celsius on certain areas on the surface, the temperatures on the outer areas can be close to 15 degrees Celsius lower. That might cause adhesion problems if the 300 by 300 area needs to be fully used. Keep that in mind. In addition, both beds are far from being nicely flat, straight or even. That's why both heavily depend on bed mesh leveling and their probing methods. Again, the XMAX 3 goes old school with the BL Touch probe. I was a bit worried that the BL Touch probe would face inaccuracies at high temperatures. Though checking the probe's accuracy at maximum bed and chamber temperatures with Clipper's repeatability check showed that this is not the case. The K1 Max goes the state-of-the-art way with nozzle probing using load cells on the print bed. That's quite similar to Bambu Lab printers, but the K1 Max lacks a nozzle cleaning device like a wiper or a poop chute. That forces you to assure before every print that the nozzle as well as the rear area of the bed is super clean before starting the prints. And even then, the actual process for the K1 Max, which is implemented to keep the nozzle from oozing during preparation, doesn't work very well. The print bed looks like a mess after some printing hours. Both printers feature rather compact toolheads and both seem to be inspired by the Bambu Lab X1 and P1 toolhead design and package. Both feature direct drive extruders, of which both seem to be inspired by Bondtech's LGX design. Both their solutions for filament runout are not integrated at the toolhead and not very elegant and rather cheaply appealing external lever switch designs. Both toolheads carry cambers via USB-C boards, which also integrate the acceleration sensors in order to measure the resonances for input shaping. At first glance, the hot-end integration of the X-Max 3 seems like a total knockoff of the Bambu Lab design for their Core XY printers, but they use a ceramic heating core similar to the Fader's Rapid hot ends. The K1 Max uses a similar approach, but with a bimetal heat break detachable from the heatsink. On the one hand, it's nice to see that both printers use easy-to-change nozzles with common M6 threads. On the other hand, I wonder why they go proprietary concerning the length versus regular volcano nozzles. I bet it should be easily possible to use standard volcano nozzles on both anyways. As the K1 Max nozzle has a hardened steel tip, you can go with abrasive materials right away. The X-Max 3 comes with an extra hot end carrying a hardened steel nozzle. Marketing states 350 degrees Celsius as well as 35 cubic millimeters per second flow rate for the X-Max 3 and 300 degrees Celsius as well as 32 cubic millimeters per second flow rate for the K1 Max. Let's verify that. Those values can limit the speed you can go with those printers, depending on material type, filament type, manufacturer, and even color. Let's verify this with a range of PLA, PETG and ABS filaments using Stefan's automated flow rate test tool. To learn more about this procedure, I recommend watching his video. Everyone can do this. As both printers come with their own high-speed PLA filaments, and because many manufacturers sent me their takes on high-speed PLA filaments, I wanted to extend the PLA test for this video. Concerning the extrusion performance of regular PLA, the K1 Max is clearly ahead. It still extrudes at printable rates when commanding 27 cubic millimeters per second. That's nowhere near the advertised 32 cubic millimeters per second, but it's imaginable that elevated temperatures or other types of filament could confirm the advertisement. The X-Max 3 falls behind. Advertised at 35 cubic millimeters per second, it struggles already at less than 21 cubic millimeters per second. That's far from the advertising and around 20% behind the K1 Max for regular PLA. Same tendency for the PETG test. For Polymaker's Polylight PETG, the K1 Max gives up at 19 cubic millimeters per second, whereas the X-Max 3 is game over at less than 15 cubic millimeters per second. Keep in mind, there are PETG filaments that extrude way worse than Polymaker's PETG. The results here in relation to PLA are quite typical though. Looking at the very popular ESAN ABS Plus, the results are as expected and a bit higher than Sunlu's PLA. Around 30 to 31 cubic millimeters per second for the K1 Max, and again, the X-Max 3 is behind at 25 cubic millimeters per second. Kudos at this point to Creality for claiming quite viable extrusion rates in daily printing scenarios, at least for ABS Plus. Let's also compare some of the high-speed PLA filaments I got over the last months to regular Sunlu PLA. QIDI's Rapido PLA, which came with my printer, doesn't show much advantage over regular PLA on both machines. It's quite the same for Creality's Hyper PLA, not really worth going for the manufacturer's high-speed filaments. A measurable difference can be seen at least with Polymaker's brand new Polysonic PLA, which performs roughly 2 cubic millimeters per second better than regular PLA, at least on the K1 Max. It seems like the QIDI X-Max 3 doesn't profit at all from high-speed filaments, also not from Polymaker's Polysonic PLA. I assume, but that would be content for a dedicated video, going at higher hot-end temperatures and with higher torque extruders, printers could profit way more from high-speed filaments in relation to regular filaments. My personal take on high-speed filaments: I don't want an extra branch of filaments, and I don't think anyone really needs them except the manufacturers. What consumers need? High-flow optimized regular filaments instead of an extra product line of filaments. What do you think about that craze on high-speed filaments? Please tell me in the comments. Let's start printing and having some fun. Let's check the advertised speeds and accelerations of 600 mm per second and 20,000 mm per second squared, like advertised for both printers. The idea is to print at 200% 3D Benchy to assure speeds are reached as often as possible. It doesn't have to be pretty, but I want to see if it finishes and what we can find out about the limits of these printers. We used the high-speed PLA filaments coming with the printers, but at elevated temperatures of 240 degrees Celsius in order to help a bit with the flow rate needed for this. All prints in this video, also this one, are done with the manufacturer's slicers. QIDI recently switched their official slicer from the Cura-based QIDI Print slicer to Prusa slicer-based QIDI slicer. No, QIDI, that's not confusing. It's basically a rebranded Prusa slicer 2.6 with some helpful additions. In the Filament tab, we get additional settings for pressure advance, as well as the chamber heater. Additionally, there's an extra tab for the Fluid UI to control the printer directly from the slicer. There's also a tab called Guides, which features helpful tutorial videos around the printer. That's very convenient if you ask me, for both beginners and advanced users. Creality Slicer Creality Print is a rebranded and partly advanced version of Cura. Creality actually improved Cura exactly where it needs to be for fast printing. Creality added settings for speed and cooling in relation to overhang angles. Creality also added a device tab and implemented their Creality Cloud, on which I'll comment later in the conclusion. In order to verify the advertised speeds and acceleration with that 200% 3D Benchy, I chose to use a common line width of 0.45mm and layer height of 0.15mm. This will command a flow rate or volumetric speed of up to 40.5 cubic millimeters per second. 40.5 cubic millimeters per second peak should be challenging for those printers. In the slicers I turned off everything which is potentially speed limiting, like relative overhang speeds as well as automatic cooling, and set all speed and acceleration values like advertised, and I expected the worst. The K1 Max finished this task without real difficulties. Movement is quick as well as nice to watch, and the finished print doesn't look too bad. Yes, there is ringing, and yes, nozzle pressure was too high for the given pressure advance settings, but I was surprised that it even finished so nicely. The XMAX 3 is a different story. Besides some artifacts, it didn't look too bad for the machine at the beginning. Nevertheless, it struggled from filament debris due to under-extrusion on the top solid surfaces of the ship floor. As a consequence, the less beefy XY motors of the XMAX 3 faced layer shifts, and as a consequence it did not succeed in this little competition. The XMAX 3 is operating closer to its limits than the K1 Max, that is for sure. Now let's get back to real-life printing, which is, concerning speeds, acceleration and flow rates, far off from the advertising. An actually sliced speedboat at settings according to the rules of the speedboat race roughly takes 30 minutes on both printers. Looking at the results, the XMAX 3 speedboat came out faster and better quality in comparison to the K1 Max one. Both struggle from stringing, but it's a bit less dense on the XMAX 3. Layer stacking is nice on the XMAX 3 Benchy. The K1 Max one looks overdone, concerning acceleration and or speed. All in all, it looks a bit warped, and for my taste concerning overall quality, the K1 Max Benchy is very close to not acceptable anymore, versus quite okay on the XMAX 3. I also printed the torture toaster on both printers with the included high-speed filaments. It tests accuracy and also to some extent overhangs. Clear winner here is the XMAX 3. It's crispier, has better overhangs, and accuracy is okay. I also tried a big one, a 300mm Deadpool bust with Polymaker's Polyterra PLA on both. The XMAX 3 delivers nicely. It looks sharp, hardly any ringing, the details are there, and the overhangs are printed very nicely. The K1 Max print looks just, I'd say, acceptable. Again, one side of the overhang is a bit off with strings attached, loads of ringing, and again, it looks a bit blurred. In order to test PETG printing, I chose material for print silver PETG and a model of the Eiffel Tower. It's a challenging model concerning retracting as well as oozing and concerning bridging. Stringing is quite okay on the K1 Max, but it fails on the bridges. Concerning the geometry of the diagonal struts, the print looks a bit better on the XMAX 3, but suffers more from stringing. Bridges and overhangs performed better too on the XMAX 3. In general, their default and generic profiles work mostly, but as you can see, there are specific drawbacks concerning print quality on both. That's also the case for ABS printing. Both succeed in producing usable parts, but they don't look very nice. The layer stacking is just not nice out of the box with default settings. The XMAX 3 is a nuance better though. TPU printing, you say? Sure thing, let's try that. I again chose the Voronoi 3D Benchy, and it's still not a typical print scenario for TPU. Crazy overhangs, super fine structures and a lot of retracting. A print from hell for every 3D printer. Stringing is everywhere on those prints, but be careful choosing a winner here. I suspect the Saint Smart TPU filament has quickly gotten wet during the print on the XMAX 3. So just note for yourself, both machines are capable to print TPU. Anyways, let's move on to industry grade, like the XMAX 3 is advertised. We have an actively heated chamber on the XMAX 3 and a print bed heating up to 120 degrees Celsius. K1 Max only has a 100 degrees Celsius bed and the chamber heats up passively. When planning the prints and materials for this comparison, I honestly was a bit clueless which materials people would want to print with an XMAX 3. Peak? Still not possible. Please tell me in the comments, which materials would you want to print on the XMAX 3 when buying it? Mostly every material in the con and prosumer market, printable with an enclosed chamber and around 100 degrees Celsius bed temperature. QIDI also sells filaments. Their high performance and most demanding filaments are fiber ABS, PET or PA12 composites. The only filament on their website officially recommending active chamber heating is their ABS GF25 with 25% glass fiber. So I ordered one spool of that on Amazon to check the printer's performance on that. I print the Warren Stealth Burner printhead for my Trident build as that one likes to warp at those sharp edges. The QIDI default filament profile for ABS GF25 is set to 100 degrees Celsius for the print bed and the active chamber heating aims at 55 degrees Celsius, activated at second layer. Having the print bed at its maximum of 100 degrees Celsius, the K1 Max heats up to 38 degrees Celsius chamber temperature after waiting 30 minutes. This is what you have to keep in mind if chamber preheating is necessary for your print. Using the active chamber heater on the XMAX 3, it only needs 10 minutes to preheat to 45 degrees Celsius chamber, with the bed temperature being set to 100 degrees Celsius. The bottleneck is actually the print bed. On the XMAX 3, I switched to the included extra hot end, which is equipped with a hardened steel nozzle, as we have seen before. The hot end swapping procedure is easy to do on the XMAX 3, but requires to remove 6 screws and some time. That's not necessary to do on the K1 Max, because it is already equipped with the hardened steel nozzle tip by default. In this shot you see a screen recording of the XMAX 3 Fluid UI for Clipper and the footage of the cheap USB camera I used to upgrade the XMAX 3 to the year 2023. With the integrated camera of the K1 Max, it automatically produces time-lapses out of the box as seen here in its original resolution of 720p. What we also see? No warping at the critical edge. Carbon fiber parts mostly always look good, as the fiber does a great job in hiding artifacts. Same as sparkle filaments, by the way, which are absolutely useless in order to showcase the print quality of a printer, so don't get fooled. What we can also spot? Here the K1 Max definitely does a better job at the bridges than the XMAX 3. We also have the usual ringing on the K1 Max part, which can also be seen on most prints except the Eiffel Tower. Despite this, both parts would absolutely be usable from a functional point of view. All in all, print quality is definitely better on the XMAX 3. Print times are around equal. The print quality on the K1 Max is not super bad or disastrous, but it's not good either, and honestly, I am disappointed. The K1 Max rather seems to be an effortlessly scaled up version of the regular K1. The K1 Max desperately needs reinforcements on the frame. Vibrations dominate the print quality. The K1 Max shines with its looks, but Creality missed it to upgrade the unstable K1 bases. The quickly added additional rubber feet don't help much there. Its genetics fail. Yeah, it has modern nozzle probing, comes with an integrated camera and has a LiDAR, and all this costs $100 less than the XMAX 3. But $900 still is an investment which can be done more wisely. For $100 more than the K1 Max, the XMAX 3 has a bit more build volume, comes with a chamber heater and has better print quality. Nevertheless, the XMAX 3 needs a ton of space, comes with an outdated probing method and leaves you with a constant fight to adjust the set offset manually. Annoying if you ask me. Also, it's held back by its slow print bed, which is DC heated. In addition, both K1 Max and the XMAX 3 struggle at delivering good first layers constantly. Achieving good first layers is kind of a gamble on both, even more if you switch materials and therefore bed and nozzle temperatures very often, like I did in this review. The LiDAR and the AI functions of the K1 Max don't help much. It's just a gimmick from my point of view. Ouch. One sentence about Creality Cloud on the smartphone. After I saw the spamming and advertisements happening on MPOX.de's YouTube channel, I didn't even want to install the smartphone app. What's also happening? A horde of bots are spamming the comment sections of YouTube videos lately, praising the K1 printers. I don't blame Creality for that officially, but it's very suspicious nonetheless. Now what's my recommendation? After elaborating the disadvantages on both our weeks, I personally wouldn't buy neither a K1 Max nor an XMAX 3, and I'd rather wait for the next generation. Both seem half-baked and both have their specific annoyances. That's why you also won't find affiliate links for them in the description. I can't recommend those with clear conscience. But ask yourself, do you really need that build space? The Bambu Lab P1S gives you a way more polished, hassle-free and high-quality printing experience, even without the multi-material AMS. The display is inferior to both XMAX 3 and K1 Max, but the software infrastructure on smartphone and PC works so well that you won't even use it much. And if, it still does the job. I know that's not for everyone, but still worth recommending. With Voron, Radric and VisiBot printers, there still are do-it-yourself options which easily exceed print speeds and print quality of the K1 Max and XMAX 3. Of course, they need time and skill to build, but they're fun projects on their own. Now, what's your take on big and fast? Please let me know in the comments. And hit the like button if you enjoyed my video, or if it helped you. Share with your friends and subscribe for more. Thank you very much for watching. Concerning the overall appearance of both printers, please leave a comment.